Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about hyperconjugation. Friends, resonance involves delocalization of pi electrons, leaving the sigma bond untouched. However, in some cases, a sigma bond and an adjacent pi bond may be involved in resonance. Such a delocalization is called as hyperconjugation. You can see here stabilizing effect of the molecule. Interaction of sigma bond, example CH or CC, with a pi network. When a carbon possessing at least one hydrogen is attached to another carbon bearing an unshared orbital or to an unsaturated carbon, there are more than one structure or canonical form possible for the molecule. These result from the overlap of the bonding electrons of CH sigma bond with 2p or pi orbitals of the adjacent carbon atom. As a result, the bond between carbon and hydrogens does not exist anymore. The shared pair of electrons is now borne by carbon alone, and hydrogen is in its close proximity as proton. The negative charge developed on the carbon atom delocalized by overlap with adjacent p orbital. You can see here this carbon has positive charge, empty 2p orbitals, and this is CH. So this is hyperconjugations. So hyperconjugations, no bond resonance. The electrons of the sigma bond between C, carbon and hydrogen are involved in delocalizations. In a structure to the right, no bond between carbon and hydrogen due to migrations of sigma bond. Hence, the hyperconjugation is also called as no bond resonance. This does not indicate that hydrogen is completely detached from the structure, but some degree of ionic character in the CH bond and some single bond character between carbon-carbon double bonds. Look at here. Such an interaction is also referred to as heterovalent or sacrificial hyperconjugations. This is so named because the contributing structure contains 2 electrons, bond less than the normal Lewis formula of the compound. At present, there is no evidence of sacrificial hyperconjugation with neutral hydrocarbons. What is the effect of hyperconjugation on the chemical properties? Alkyl cations and their relative stability. Carbocations have an electron deficient positively charged carbon. The empty p orbitals of this sp2 carbon can overlap with sigma orbital of CH bond of adjacent alkyl group, alpha CH bond. This overlap permits individual electrons to help bind together 3 nucleus, 2 carbon and 1 hydrogen. The positive charge thus gets dispersed over large volume of space and is stabilized. You can see here. The more the number of alkyl groups on the carbocation, more is the number of alpha CH sigma bonds, and hence more are the possibility for hyperconjugation, which makes the carbocation more stable. The order of stability of carbocation is 3 degree, greater than 2 degree, greater than 1 degree, and greater than methyl. So 9 hyperconjugation hydrogen, 6 hyperconjugable hydrogen, 3 hyperconjugable hydrogen, no hyperconjugable hydrogen in methyl radical. Alkyl radicals and their relative stability. Alkyl radical have p orbital of carbon occupied by an odd electrons which gets delocalized over 3 nuclei, 2 carbon and 1 hydrogen by the overlap with the sigma orbital of CH bond of adjacent alkyl groups. The bond is formed between 2 carbons and odd electrons is held by the hydrogen atoms. Now, the order of stability depends on the extent of delocalization. The greater the delocalization, the more is the stability. 3 degree greater than 2 degree greater than 1 degree greater than methyl radical. Now, alkene and their stability. Overlap of sigma orbital of CH bond with pi orbital of the adjacent carbon-carbon double bonds give rise to canonical structure. Delocalization of electrons occur over the 3 nuclei and thus stabilizes the alkene, pi bonds and sigma bond. Alpha CH possesses partial ionic character and its electrons get delocalized into the adjacent pi system. More the substituents, more is the opportunity for hyperconjugation and more stable is the alkene. You can see here. The stability of alkene with increase in the number of hydrogen alpha to the unsaturated system. Increasing order of stability of alkene because of hyperconjugation. You see number of hyperconjugable hydrogen 0. If you have CH3, CH, double bond CH2, 3. Here you can see 12, 9, 6 like that. Bond length. Hyperconjugation leads to shortening of sigma bond. Example, carbon-carbon bond in 1,3-butadiene and methyl-acetylene is 1.46 angstrom in length, much less as compared to 1.54 angstrom found in saturated hydrocarbons. For butadiene, this can be explained by the normal conjugation of 2 alkenyl parts, but for methyl-acetylene, hyperconjugations between alkyl and alkenyl parts. Anomeric effect. The general tendency of anomeric substituents to prefer an axial orientation is called as anomeric effect. Alpha methyl glucoside is more stable than beta methyl glucoside due to hyperconjugation. In beta methyl glucoside, the methoxy group is at equatorial position and cannot involve in hyperconjugation. Therefore, beta methyl glucoside is less stable than the alpha methyl glucoside. Alpha methyl glucoside you can see here and beta methyl glucoside. Baker-Nathan effect. Alkyl groups are electron donating. The relative magnitude of this inductive effect of alkyl group is 3 degree greater than 2 degree greater than 1 degree greater than methyl. This order is reversed when an alkyl group is directly attached to an unsaturated system, whereas the release is maximum, electron release is maximum for CH3 and the order is 3 degree, CH3 greater than 2 degree greater than 1 degree, 2 degree greater than 3 degree. This is known as Baker-Nathan effect and was explained by Baker-Nathan on the basis of hyperconjugation. Look at here the toluene. In CH3 there are 3 hyperconjugable hydrogen atoms, thus more stabilization by hyperconjugation. In CH2 CH3 there are only 2, in CHR there is only 1. This explains the reversal of order where electron release is not by inductive effect but by hyperconjugation. Friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.